Hmm. Okay, let me see if I can just share this and see you guys. Yeah, it worked. Okay. So yeah, I want to walk through this, what Aaron was just saying, like how do we do the analytics level data quality? And I'm going to do it through an example of doing acute inpatient data quality. So to start with, obviously, if you have an analytics ready data model, any analytics ready data model should have an encounter table. In the Tuva data model, this is the core dot encounter table. And an encounter table is basically a table that has one row for every encounter that happened across all your data. And so it's at the encounter grain, you would have, here I'm just showing a few of the columns of this table, not all the columns, but you would have one row for each encounter, and you would have different fields for interesting data elements for the encounter, like the length of stay, the discharge disposition, the DRG code for each encounter. Now, the thing to keep in mind about this table is that every row in this table, every encounter is made up of multiple claims. And there is a lot of complex logic that goes into constructing an encounter using the raw data elements, the raw claim lines that you have in your raw data sets. And so by just showing this final output table that's designed for analytics in the Tuva data model, the core dot encounter table, you have no visibility into all the complexity that went into creating a high level concept like the concept of an acute inpatient encounter. And so you might think, well, that's not an issue because I'm trying to answer some questions. And that's the whole point of an analytics ready data model. You have an output table that's designed for analytics and you can just use it to answer questions. But we've mapped a lot of data sets to the Tuva data model. And what we often see in practice is that you get to a table like this and you want to use it to answer some questions. And maybe the table is empty, or maybe the number of encounters that you see in the table is less than what you intuitively expected to see. Or maybe key data elements related to your encounters, like the DRG of the encounters or the discharge disposition for the encounter, is empty for half of your encounters or more. And so then trying to figure out why that looks off, or why something is the way it is, and then final output table becomes extremely difficult if you have no visibility into all this long chain of complex reasoning and logic that went into creating a high-level concept like the concept of an acute inpatient encounter. So that's why we're bringing data quality to the construction of the high-level concepts that are in the Tuva data model. And so the idea is the following. We basically start with raw claims data. In this case, we have individual claim lines, and then we apply a bunch of complex logic to build high-level concepts on top of your raw data. And then we populate these high-level concepts into these output tables that are designed for analytics. But what we want to do is we want to add this transparent layer where we basically see we have visibility into all these different intermediate level concepts that are built. And in order to build a final output table like an encounter table, there's basically a tower of concepts that you're building. You're building concepts on top of concepts on top of concepts, and you end up with this final output table. But we want to bring visibility into this complex chain of reasoning and all the concepts that are built in between with a data quality lens, so that if anything goes wrong in the path from raw data to final output table, you can see exactly where something went off and why, and if there's a reason for that because of the data quality problem in your raw data. So let's walk through the example of acute inpatient encounters from scratch to basically think through how would you build an acute inpatient encounter, what could go wrong in the process of doing that, and what are the different data quality issues you would want to look at along the way. So the first thing you would want to do when building acute inpatient encounters is you want to identify institutional claims that are for acute inpatient encounters. So every institutional claim has an admission date and a discharge date if it's an institutional claim for an acute inpatient encounter. And now an acute inpatient encounter could be defined of a single institutional claim, or it could be defined of multiple institutional claims that are merged into a single encounter. Then the institutional claims that make up the encounter define the beginning and the end of the encounter, as well as key data elements that are part of the encounter. So there's key fields that are assigned at the encounter level, like the DRG or the admit type code or the discharge disposition code, and these fields come from the institutional claims that make up the encounter. And then there's logic for how you would merge different institutional claims into a single encounter. So the claims could overlap and have the same facility MPI for the same patient, and so you would say they're part of the same encounter. Or the claims could be adjacent to each other, and they have the same facility MPI, and the earlier claim has a discharge to disposition indicating that the patient was still a patient. And so if these criteria are met, different institutional claims would be merged into a single encounter. And then there's also the issue of what happens when an encounter is made up of multiple institutional claims. Each of these institutional claims has key data elements, but it could be the case that they have different data elements from each other. So for example, if you have 3 institutional claims that make up a single encounter, each of those could have a different DRG, and you want to assign a single DRG to the encounter at the encounter level. So there's logic for how you would pick individual data elements from different claims making up the encounter to assign those data elements at the encounter level. And there's rules for selecting some of these data elements from the first claim in the encounter and other data elements from the last claim in the encounter. And then there's also professional claims. So professional claims are individual bills that overlap with your encounter. The encounter length was defined by the institutional claims, but you need to sum up the paid amounts from professional claims that were part of the encounter to account for the total paid amount for the encounter. And so that money needs to be rolled up to the total cost of the encounter. And so how do you identify the institutional claims that make up the encounter in the first place? Well, there's 3 key data elements that it could indicate an institutional claim is an acute inpatient institutional claim. You can have a bill type code that is for inpatient hospital. You can have a DRG that would also be indicative of a claim being an acute inpatient claim. Or you could have room and board revenue codes that could also indicate that particular institutional claim is an acute inpatient claim. So if you look at the Venn diagram of those 3 key data elements, in the Tuva project, we used to define acute inpatient claims as claims in the intersection of the 3 areas right here. So basically claims that have all 3 data elements would be acute inpatient institutional claims. More recently, after doing analytics on a lot of different data sets in the Tuva data model, we have decided to relax this definition and to say that an institutional claim is an acute inpatient claim if it has a valid DRG or if it has a bill type code for acute inpatient. And the reason we decided to do that is because it became obvious that revenue center codes are sometimes missing or unreliable. And it just makes more sense to say that if a claim, it didn't make a lot of sense to say that if a claim has a valid DRG, it's not an acute inpatient institutional claim just because it was missing a room and board revenue code. And so this is how we define acute inpatient institutional claims currently in the Tuva data model. And then separately for professional claims, how do you identify professional claims that are part of an acute inpatient encounter? These are simply claims that have inpatient hospital as a place of service. So you can see along the way to construct an encounter, there could be so many different variables that you might want to see if they make sense as you're building this up. You might be curious to see what percentage of my acute inpatient encounters are made up of a single institutional claim versus multiple institutional claims. What percentage of my acute inpatient encounters have professional claims that roll up to them? And for those encounters, how much of a dent do the paid amounts from the professional claims make on the total paid amount for the encounter? All kinds of questions like that could be making an impact on the final encounter table, and you want to keep track of those things along the way as you construct the encounter. So as we've seen, we start with the raw claim lines. We build these high-level concepts using a lot of complex logic, and we show intermediate steps along the way. And the way we want to do this is we want to build these output tables into the Tuva data model, and we built one for the example of acute inpatient encounters. And so I'm going to switch gears here and show you what this table looks like. So here I'm inside of Snowflake. This is a table in the data model that's acute inpatient data quality summary. And this table basically walks through the entire acute inpatient story that I was just showing in the slides. It's summarized in a long table that looks like this. So you start by looking at the atomic data elements that make up that define institutional acute inpatient claims. Think things like bill type code. You can look at the data quality of bill type code across your claims. And there's a lot of things that you might want to look at. Like, for example, here's institutional claims that have a missing bill type code as a percentage of total institutional claims, or institutional claims that have a always populated bill type code as a percentage of institutional claims, etc. The final line here is the most interesting one, is institutional claims that have a usable bill type code as a percentage of total institutional claims. And you can see the same thing for other key atomic data elements like DRG. What percentage of all institutional claims have a usable DRG? What percentage of all institutional claims have a usable APR DRG versus MSDRG, etc. So I've basically, I want to look at this table for two data sets at the same time. And I have this in a spreadsheet here that I heard a noise. Does somebody have a question? So I can't see you guys right now, but if somebody has a question, please let me know. So here we're going to look at basically this output table that I was just showing. That's a table in the data model. And we're going to look at it for two data sets at the same time. These are the two synthetic data sets. The Tuva synthetic data set is a synthetic data set that we've created and are maintaining currently. And then the CMS synthetic data set that's available from CMS. And so you can see, for both data sets, I'm highlighting interesting things in red here that we can see across this entire table. But for both data sets, we have 100% of all institutional claims have a usable bill type code. In both data sets, we have very close to 5% of all institutional claims having a usable DRG, an MSDRG in this case, which makes sense. It's typically around the order of 5% of institutional claims that have a populated DRG. But in this case, around 5% of all institutional claims have a usable MSDRG. In both of these data sets, we don't have APR DRG, it's MSDRG that's present. Revenue center code is another key data element to identify institutional acute inpatient claims. And it's interesting to see that, first of all, in both data sets, nearly all revenue codes that are present are valid. But in the CMS synthetic data set, these are claims that have one or more usable revenue center code as a percentage of all institutional claims. Nearly all institutional claims have a usable revenue code in the CMS data set, but nearly zero claims have more than one revenue code, which is unusual. In the Tuva synthetic data set here, we see a more realistic distribution of the number of revenue codes in institutional claims, where some claims have 2 or more, some claims have 3 or more, some claims have 4 or more. In CMS synthetic, basically all institutional claims have one usable revenue code, but basically none have more than one.
This was an interesting example because the new CMS synthetic claims data set is pretty great. Like, it's way better. If you're familiar with like other data sets, CMS's synthetic data sets CMS has released in the past, this data set's like 1,000 times better. It's like 10,000 patient, 10,000 members, medical claims, pharmacy claims, eligibility. It's like a very realistic claims data set. And you can do a lot of cool stuff with it. This was an interesting finding because obviously in this regard, it's not realistic in this particular way. Not a knock against the data set. It's still a great data set. It's 10,000 times better than the DescendTough data set. But this was kind of interesting.
Yeah, exactly. And then the Venn diagram that I showed before, having basically this Venn diagram, the key data elements for an acute inpatient claim. There's a summary of that in this table as well. You can see, for example, how many claims have room and board rev codes, how many claims have a valid DRG, how many claims have a bill type that's for acute inpatient stay. But if we define acute inpatient stays or acute inpatient claims as claims that have either a bill type code or a valid DRG, it's about 5% of all institutional claims in both of the data sets, which sounds very reasonable. And then there's a summary.
Coco, what if we went back to the stricter definition where it's the intersection of all three?
Yeah, that's a really interesting point, because that would basically cut this drastically. If you look at this is claims that have all three. These are the amount of claims. And if you look at it as a percentage of institutional claims, it's this row right here, claims that have all three things. In the CMS synthetic data set, you would have less than 1% of all institutional claims are acute inpatient. And in the Tuva synthetic data set, you would have 2.6% of all institutional claims. So by just changing the definition, at least in the Tuva synthetic, you more than cut in half the number of institutional claims. And in the CMS data set, you drastically reduce it even more than that. So by just changing the definition of how you define an acute inpatient institutional claim, your acute inpatient PMPM can change by being cut in half or more. So that's just interesting to be able to see this right off the bat here. We believe this definition that we're currently using is a more accurate representation, and it also makes more sense intuitively that you would have about 5% of all institutional claims be acute inpatient. Next in the table, there's a summary of data quality issues for acute inpatient individual claims. This is before we even merge claims into an encounter. But like we see before, there's about 5% of all institutional claims are acute inpatient. CMS has very few professional claims. That's interesting. It's about 77% of the data set is institutional claims and 23% of the data set is professional claims. So that's why the number of acute inpatient institutional claims as a percentage of all claims is very high. It's 4% of all claims because there's very few professional claims. All acute inpatient institutional claims are usable in both data sets. That means that they don't have a drastic data quality problem that makes it unusable. But a large number of claims have data quality problems. 55.4% of acute inpatient institutional claims have a data quality problem in Tuva synthetic. And these data quality problems are, you can see here basically a breakdown of all the data quality problems, but a common one is having unusable DRG. And that's just like, 12% of claims in CMS and 5.6% in Tuva synthetic have an invalid DRG. It's not a real DRG.
Coco, so unusable in this case kind of brings together multiple types of data quality problems. So it could be
that's
missing,
right.
Invalid, like multiple per claim. It's
exactly.
Kind of like
this is all broken down. I didn't go into all that detail here because there's a lot to say, but basically there could be many things that could be wrong with your DRG. It is a case, as we've seen in real and synthetic data sets, that a single claim can have more than one DRG. And so like if a claim has 10 claim lines and 5 claim lines have one DRG and 5 claim lines have a different DRG, we would say that DRG is unusable because we don't know which one it is. But it also could be invalid. It's just not a valid DRG, or there could be different things that could be wrong with the DRG.
And just another comment before you finish going through this, like this is definitely designed for a power user, right? So essentially what we've built out here is, this is like under the hood. It's like, obviously if you're doing data analysis, it's like, well, the data's in the core.encounter table, filter to where encounter type equals acute inpatient. Boom, those are your acute inpatient stays. You want to see average length of stay? Boom. You want to see, whatever metrics you're calculating related to that. But this is like when something's going wrong, or if we want to check and see if things are reasonable, this is basically bringing together all the analysis that we did by hand over and over again every time we would have to do that, and organizing it into like set chunks of things where we can be like, okay, first check this, look at this section, then look at this section, then look at this section.
Exactly.
And so it's just, again, trying to we were essentially reinventing the wheel on this by hand over and over when things were not looking right, to figure out what the heck was going on. So now we're just bringing it into an ordered framework where it's like, okay, well, now here it is. I don't have to write these queries from scratch every time. Here are the results.
Exactly. And this is back to the fundamental question is my data ready for analytics? And if not, why not? And basically, when you look, if you want to, we believe, or basically our thesis is that to answer that question, you can only answer that question on a use case by use case basis. We've worked with data sets where you can do really interesting analytics around constructing lines of therapy, for example, for different chronic diseases, but you cannot do any financial analytics on the data set. So depending on the data elements available in your data set and the data quality of those different data elements, you could be able to do different kinds of analysis really well and other kinds of analysis very poorly with the same data set. So the question of, is my data useful for analytics or ready for analytics, depends on the use case. And so basically this is an example of doing this for the use case of doing acute inpatient analytics. You have your output table with your final acute inpatient encounters, but that might or might not look reasonable, and you have no visibility into how that was constructed. And this table here is basically a detailed summary of everything that went into constructing that table, so that you have that visibility, and you can compare that across all your data sets very easily.
Coco, I'm just noticing a question in the chat. Chris Fouch asks, institutional claims either come at the end of the stay. Institutional claims come at the end of the stay, while professional claims show up as they occur. What happens to professional inpatient claims that don't have an anchor claim? I actually think we have some analytics around identifying those.
Yes.
But in general, it's a good point. It's a good point, Chris. And those will essentially be orphaned until their anchor event or their anchor acute inpatient institutional claim eventually shows up. And so that one complication of that is that can kind of like change your results over time as you're getting more data refreshing. There's various ways to handle that, but it's a good thing to be cognizant of.
Exactly. And I'll talk about that in more detail in a minute. Basically, here, when you have acute inpatient encounters made up of multiple institutional claims, there are data quality issues that could be specific to those types of encounters. And these are data quality issues specific to multiple claim encounters, because you could have multiple institutional claims that have different values, for example, a DRG. And that happens in these data sets. So you can see how often the claims are obviously being merged into a single encounter, and they have different DRGs. And so this just gives you an idea of how often these kinds of data qualities are happening in your multiple claim encounters. Then rolling up professional claims into acute inpatient encounters, we again start by looking at the atomic data quality of place of service code, which defines a professional claim as being an acute inpatient claim. You can see here in both data sets we're looking at, all of the populated place of service codes are valid. It's also interesting that in both data sets, we have one place of service code present in all professional claims, but zero professional claims have more than one. So that's unusual. You would see often more than one place of service code in a claim.
Yeah, I don't even know that the Tuva synthetic is very realistic in that regard. But
yeah. And yeah, here's a summary of professional claims. Only about a third of professional claims are usable in the CMS synthetic data set. They usually have, so a lot of them have problems with their dates. They have a start date that is after the end date. So that's makes it so that we can't really place a claim in time accurately, so we're not using them. There's usable professional claims overlapping with institutional claims. So basically all usable professional claims for CMS synthetic data overlap with just one encounter. So that's good. But in Tuva synthetic, only 55.4%, because 43.8% of all usable professional claims overlap with no encounters. And
so this is Chris's question.
Exactly, this is this question. So like 43.8% of all usable professional claims are orphaned. They don't overlap with an encounter, and so therefore we're not rolling up those dollars to any encounters. And here's a summary of the final summary of acute inpatient encounters. Here we have interesting things about the final encounters. There's a significant number of encounters that have some kind of data quality problem. This is interesting that 95% of all acute inpatient encounters in both data sets are made up of a single institutional claim. So even if we have a very sophisticated merging algorithm to merge individual institutional claims into a single encounter, but even if that didn't exist, you're still capturing 95% of all encounters with single claim encounters. Most acute inpatient encounters in Tuva synthetic have professional claims, 95% of them, but most acute inpatient encounters in CMS do not have any professional claims that roll up to them. That's also interesting to notice. And the spend that comes from professional claims is negligible, because basically, as seen as a percent of the total spend on encounters, it's very close to 0%, which makes sense. But this is, again, synthetic data set. It would be very interesting to be able to see this across all of your claims data sets at a glance. And so that's and then we have things like the death rate and acute inpatient encounters in both data sets is reasonable, is pretty low. Average length of stay is 3.6 versus 2.8, and the average paid amount across both data sets, we can see that too. But basically, our grand vision for this approach is that we could be able to see all the lineage of intermediate concepts that are used in constructing something like an acute inpatient encounter at a glance in one view, and that we could see this across all our data sets. So that if you have any question about what percentage of my total encounters are made up of multiple institutional claims, what percentage of my total encounters have professional claims that roll up to them, things like that, you can immediately see this across all your data sets and see what's reasonable and what's not. And this is like the full lineage of logic and intermediate concepts that are used to build something as simple as a single acute inpatient encounter. And so this is obviously designed specifically for this use case, but an analogous lineage view of concepts can be built for every single use case. And that's our view for what data quality could be in Tuva, basically having a full table like this for every use case of interest.
And the thing that really enables, because if you think about, okay, we're building all these data marts that enable more rapid analytics. There's only like two approaches to doing that. There's only two ways we can know for it, because it's not like we can't look in the back of the math textbook and be like, oh, did we get the right answer, right? There's no like clear correct answer for building acute inpatient encounters from claims. As Coco just went through, there's multiple ways to do that, and that's true of like almost anything that we're doing. So as we think about trying to get to the right answer for all these things, there's only two approaches. One approach is we can like be smart about it, right? And so what I mean is, all of us who have worked in the industry for a long time doing this sort of analysis, we have accumulated this knowledge around the data generation process, how claims are generated, how care is delivered, how that translates to the data being generated, and then what that data means when we're analyzing it. So we can use that information to try and build good methodologies. And like that's basically the fundamental thesis of why the Tuva project exists, is like we think that we should be developing this out into the open. We can get to a better answer by having everybody kind of weigh in on it. So that's one approach, and that's good. But the second approach that's important is like being data driven about it. And so this is an example of how like this is the full data quality lineage of acute inpatient encounters. And because this is then just another model, another data table in the Tuva project, anybody who runs the version when this is released can immediately go look at this table. And then as we're having conversations, we can start to Coco brought up about the revenue center thing. And we decided over time to phase out that restriction, because we were doing this type of analysis across multiple data sets. And we're like, look, we're getting to a fundamentally different answer that doesn't feel like a good answer. And so our vision is like, there's thousands of data sets. If we can transparently see the quality lineage of how we're computing these things and what the impact of that is on the results, then over time that'll help us converge to a better answer as well.
Yeah, exactly. One of the things that has always been really interesting to us is how drastically some of these measures can change by changing the definition of simple concepts that are used to build them. And we've seen examples of PMPMs changing by 80% or something because we changed some definition in the process. And so, yeah, this is extremely interesting to us to be able to compare little changes in logic across multiple data sets and the effects that have on the final output tables for analysis.
Got another question in the chat from Andrew Mondo. What's up, Andrew? Does place of service of the professional claim factor into the logic? Orphaned inpatient place of service professional is different than office place of service, right? I'll take a stab at it, but keep me honest. I think we're only including place of service codes. The only professional claims that get merged into the encounter are professional claim lines that have a place of service code equal to 21, which is inpatient. If the place of service code was 11, which I think is office visit, that wouldn't get merged in.
That's correct.
Gotcha. Yeah, that 43% seemed high, and so I was wondering if those were all just office claims that wouldn't have a a corresponding facility. But yeah, it makes sense how you guys are doing it.
It's also synthetic data, so that would be my guess what the issue is. In the future, when we do more of these, we're going to bring in more data sets. One in being the CMS limited data set, which is actual Medicare claims, so we can see like how it looks on some more realistic data.
Why would you want to exclude those though, and not say that it's a place of service miscode? I mean, if they're inpatient, they're not leaving the hospital, like they're there, right? Physically.
Yeah, it's a good point. There's probably something we should check. Doesn't sound like we have this built into the data quality lineage right now, but it would be interesting to know essentially how many like professional claim lines that have some other place of service code not equal to 21 are happening during the
duration.
Yeah, during the duration.
Yeah,
it should be zero. Basically, I'm sure it's not, but it should be. There.
Yeah, but that could be just they have the wrong place of service code.
I had one other question about the quality metrics. Is there like does it make sense to have kind of a final high level score to say, okay, here's all these statistics, and these are the ways that it is reliable and maybe the ways that it's not reliable, to kind of try and map out your use case you're trying to do and make a decision. But like, is there like a, this is 95% reliable, or maybe even by category, this is 40% reliable for financial type analytics, this is 60% reliable for some other type of purpose.
Yeah, I mean, honestly, we've thought about this a lot, and it's been very difficult to come up with like a really good grading system.
Context matters.
Yeah, context. Aaron has some funny stories about sitting in rooms with people who say we need a data quality system and decide it out in the abstract. And
I've been that person. I'm like, there's so many meetings with executives being like, we need a data quality grade. And then like, they whiteboard it all out for 4 hours and it's like, we solved world hunger. And then like you give it to the people to implement and they're like, this is stupid. Like this is absolutely meaningless. And I can say that because I've done that multiple. I've been the problem multiple times. But yeah, I think maybe. I think where my current view on it, Chris, is like some overall data quality grade. Like your data gets a 92%. Like, no, if any vendor is telling you that, or if anybody's, it's like that's complete marketing BS. But I think maybe you could get down to kind of like a domain level. I think maybe you could do that. But even within the domain, there's going to be a nuance, kind of, right?
Kind of depends on the question you're asking.
Yeah,
exactly.
The context matters.
Context matters, and it's very use case specific.
It's like Coco didn't go over any, like obviously one of the things we're doing on the acute inpatient claims is we're rolling up the paid and the allowed amounts to be able to calculate the average cost of the encounter, right? Which is one of the benefits of grouping all those different claims together. But Coco, none of the merging logic actually depends on that. So we could do everything that we just looked at, but the total paid for the encounter and the total allowed for the encounter could just be 0 all the way down. And so actually, so for that particular use case, it's like, well, that's not very good data quality. Unless, we had a sale, it was like free day at the hospital or something, which I don't think was the case.
Thank you.
Yeah, great question. We'll just open up to any other questions or comments. We've got a few minutes left. Coco, we didn't have anything else prepared that we wanted to go through, right? This was
Yeah,
kind of
no,
it.
I'm going to chat about any questions anybody else has.
I have a quick question if you guys don't mind.
Yeah, go for it.
Yeah, so these like lineage type tables, they're not available in the current rev. Is that right?
That's right. Yeah, these are going to be released in a future version.
Okay, awesome. Thank you.
And I get maybe kind of a call to action. So we've been talking with a few different folks or different groups in the community about building more concepts, more data marts into the Tuva project and doing it in a collaborative way. For example, we have folks in the community that have a lot of expertise in different areas. Some people are like, I know a ton about chronic kidney disease. I know a ton about orthopedics or different areas. And so as we go to as we're looking for more folks in the community to partner with to build out those sorts of things, and as we build those sorts of things, we will simultaneously be building kind of in this way, so we can see the effects of our decision making on the methodology, and then kind of as we roll that out, it'll be really interesting as people start to adopt it, and we can get feedback on kind of the impacts of the methodology just by looking at that single table. So there's probably we haven't it's like in the early stages of thinking about this, but what we would love to do is enable the ability to upload the results of that table to some shared place where we could look across a bunch of different data sets. None of it's PHI because it's all aggregated, but can we do it in kind of a way that anybody could access and then see hey, here's what it looks like on my data, and here's how it compares to a bunch of other data sets. And then that's how we tap into not just the expertise, but the okay, let's be building this in a data-driven way across a lot of data sets. So we're still trying to figure out how that would actually work. But more to come.
Cool.
All right. Edward, were you going to ask a question? I thought I saw you gesturing.
Yeah. I was going back to the issue of DRGs and institutional claims and claims having different DRGs for the same encounter. Is that because coders are entering a DRG prematurely and maybe gets changed later, or do you know what might be the cause of that? I work in acute inpatient analytics, but don't really deal with institutional claims. So I hadn't heard that was something that happened previously. So it was interesting to kind of listen to your lecture and see, how acute inpatient data sets are assembled differently from the ones that I work with, which come from, the professional side as well as EHR output data. So yeah, Coco, I don't know, or if anyone else on the call has insight into.
I'll share. I have a thought on it that I'll share. I think that what this comes down to is, I think most of the time, I think mostly what's happening here is probably not, strictly speaking, a data quality problem. It's just kind of a rare thing that happens. It's I got hit by the bus and it was a really long hospital stay, And initially it was like, you know, a bunch of broken bones and trauma and putting my body back together. But then, gosh darn it, I got sepsis.
Sepsis, yeah.
It's always sepsis, right?
Right.
And then like in the course of my very long hospital stay, that DRG then kind of, you know, changed over time. That would be my guess, kind of.
Mhm.
And you know, when we're trying to roll things up to an encounter level, we have to like make decisions basically about what, you know, we kind of got to pick the DRG.
Right.
So I think that's that, you know, at least in the synthetic data, for example, that's happening like a very low percentage of time. And I think that's probably the case in real data as well, but I don't think it's actually a data quality. I mean, it could sometimes be, but you know, the claim was paid, and you know, getting the DRG right is an important part of the adjudication process, probably the most important, because that's the going to determine how the paid amount, the allowed and the paid amount, more than anything else. So
Yeah.
yeah,
Our challenge is we often, I say often, it's probably about 20% of the time, 15 to 20, we don't get that final DRG. Again, because we're not working with the institutional claim. I mean, I'm sure that the percentage of claims with MS-DRGs is extremely high, right? You know, we're getting EHR data. So I think at some hospitals that DRG doesn't always cleanly find its way back into the patient record, in the health record.
Yep.
Even if it is in the, you know, the revenue cycle records. So.
Yeah, I mean, this is really interesting because we've been talking about how answering different kinds of questions, you might want to go to different tables in the data model. If you want to look at, like, so there's a medical claim table that has obviously every institutional claim with its corresponding DRG, but it's only when you want to group these claims into a single encounter that you have to assign a single DRG to the encounter, and that gets populated in the encounter table. But similarly, so if you want to look at, for example, paid amounts by DRG, you could query the encounter table and look at the paid amounts of each encounter with its DRG, or you could query the medical claim table, and each individual claim has its paid amounts in the DRG, and you would get a different answer. But similarly, if you look at PMPMs, you can calculate the PMPM using a medical claim table, where every claim gets assigned, you know, has its paid amount, and you can calculate, and gets assigned to service categories. You can calculate PMPMs through the medical claim table. But if you wanted to look at the acute inpatient PMPM, you could query the encounter table directly and only look at encounters that are acute inpatient. The difference is that encounters in the medical claim table, when you calculate PMPM, at least in the Tuva data model, we only take medical claims that have coverage. Like if the patient had eligibility in the time frame when the claim happened, then that gets rolled up in the PMPM mart into a PMPM. But in the encounter table, it doesn't matter if the patient had coverage for only, so if an encounter was a few claims and only one of those claims had eligibility, not the other ones, we would roll up all these claims into the encounter and a full encounter start and end date. And so you are including claims in the encounter table that make up these encounters that might not have had coverage. And so this is just one example of how, like, when you build a concept, you might be building many different concepts in a very large data model, and you're making decisions for how you build each concept. And that could lead to, it could be possible to answer the same question in two ways using the same data model and get slightly different answers, because you're building these concepts in, you know, for different use cases in different ways. So I actually had a conversation with Brad earlier this week on our team about exactly this, like how you want to include all claims in an encounter, even if a claim did not have eligibility, because that defines the entire length of the encounter. But you don't want to sum those claims up when you calculate a PMPM if the claims don't have eligibility. So that's just, you know, that's one example of that happening.
Yeah. All right, we are at time. Thanks everybody for joining. I will throw this video up so that people can watch if they weren't able to join. Everybody have a good holiday. We'll see you in 2025. Take care.
See y'all.
Thank you.
Thank you.